Cynthia, how do you find a y-intercept? Make x equal to 0. F of x equals 2 times 0 plus 4 and 0 plus 3. Class, 2 times 0? 0 plus 4. 0 plus 3. F of x, we made x equal to 0. Should have made it 0. Equals 4/3, which means my order pair is 0 and 4/3. Raise your hand if you got that. Good job, Cynthia. Melissa, how do you find an x-intercept? Put your finger on the y, class. Melissa, tell us what to write now. Can you write the original? Sorry, I should have wrote the original. Not f of x anymore, right? Good. And Melissa, you told us to make y equal to what now? A rational function is just a fancy word of saying fractions. Class, what's a fancy way of saying fractions?
Rational function.
What's an easier way of saying rational functions? Okay. Talk to your partner. How would you solve for x here? Ready, set, go.
Over here, I got rid of the x, so they can just go out. Just left 2 plus 4 and then do it.
Nathan, what's you and your partner's ideas? Ronaldo. Cancel the x's. Raise your hand if you thought about that. Okay? You need to have some number sense. Think about this. If you cancel the x's, what happens to the 2?
Just 2.
It goes by 2? Okay, so then you think the answer is 4/3. Yes? If I put in a 1 there, 2 times 1 is what? 2 plus 4 is?
6.
And 6 over 1 plus 3. That becomes what? 6 over 4. If you reduce 6 over 4, that is 3/2. Is 3/2 equal to 4/3? No. So what I did is that's what I would do on a standardized test. I don't remember the properties of exponents. I'm not sure if I can cancel x's. You pick a number for x and you think, does it equal what it would be if you did not cancel it? What does that mean? I'm basically using critical thinking. I don't know the rules of math, but I can plug in numbers and figure it out. So, I can't cancel the x's. The reason why I can't cancel the x's is because they're not factors. Everyone say factors. This is separated by multiplication, but they're connected by addition. So I can't cancel x's. You could do something like this. Do you see the difference here? But you can do that if it has this. That would be a no-no. You can't cancel your x's. Okay? So we can't cancel the x's. We're trying to solve for x. Some other ideas. Okay, we're applying the properties of algebra to solving. So let's just say you want to get rid of this x plus 3. We see division. The opposite of division is multiplication. And you can also make this one a 1 over 1 and then cross multiply. Raise your hand if you thought of that. Okay, so let's just do, this will help you understand what cross multiplying means. So you're going to treat this like a whole. So I'm going to multiply both sides by x plus 3. I'm going to put this one over 1. The reason why I do that is essentially you're moving the x plus 3 to the other side. These factors will cancel. Class, 0 times anything is 0. So 0 equals 2x plus 4. Should I divide or subtract? 2x is equal to negative 4. And then if you divide by 2, x is equal to negative 2. What's my order pair? Negative 2, 0. Alright, this might be uncharted territories for you. This might be very new. So all I want us to do right now is be able to get the x and y intercepts. But let's graph it. Let's have some fun with this. Raise your hand if this is new to you. Oh, good. You guys like new, right? You go to scary roller coasters, you can't see anything. You scream, you black out. Alright, so we have 0 and 4/3. I got negative 2, 0. Let's just put those points on our graph. Zero and 4/3. Is that more than 1 or less than 1? It's more than 1. And our blue, negative 2, 0. Right or left? Left. Okay, you're thinking to yourself, can I do that? Huh? Can I just, like, draw a line? Connect the dots? Is that linear? What's different about this is you might be tempted to think it is linear, but we have a fraction here. Now, we've been talking about how you can use more values to kind of help you get an idea. Okay. Can someone think of an x value that makes the equation look really funny? Talk to your partner, 5 seconds. An x value that might make this equation look a little bit funny. I'm recording a math lesson. Students checking their phone. Right there. Does someone think of a number? Negative 3. Watch. 2 times negative 3 is? Negative 6 plus 4 is? Okay, so we know that's negative 2, right? Negative 3 plus 3 is? Negative 2 divided by 0. Put in your calculator. Negative 2 divided by 0. I don't know. Let's see what the calculator says. Who has the error? Who has the error? Not if you have it on your calculator. Who has the error? The calculator or you? What does it mean? Do we write 0? Anyone know what the answer is? Undefined. All of the x values are going to be undefined. What does that mean? Anywhere on my orange marker, you can't get anything. Can you ever divide by 0? What did your calculator say? Error. So we have something called an asymptote. Everyone say asymptote. don't touch the asymptote. The graph will never touch the asymptote. Okay, let's get some table of values. Of course, you can always pick table of values on your own. What would I do? I'd probably pick something really close to the line and further away because I want to know what's happening. Is it going to go like this? Is it going to go like that? Let's graph it. Y equals, clear it. Was that student in this class? Would you guys press alpha y equals? That was so cool. Thank you for teaching that to me. So if you didn't know that, then you can just put those in parentheses in the numerator, parentheses in the denominator. It would work. 2x plus 4 parentheses divided by x plus 3. Or hear what that one student did. Alpha y equals numerator 2x plus 4, press down, x plus 3. Does it matter which one you have? Yes or no? No, it doesn't. You're in a dream. Focus. It's having a hard time focusing. Okay, how do I get a graph? Zoom. We're trying to graph this. 3? 6. What number, class? What is this beast, right? This is called a rational function. We're just doing a quick sketch. You can kind of see where the asymptote is, where my color pencil is. Okay, I can teach you guys how to put that in your calculator, but let's just put a sketch on that really quickly. Don't worry, we're going to spend multiple days on that, but the big idea is that you'll just be able to get the intercepts. That's interesting. It looks like there's some kind of line right here, and we'll talk about that later on as well. Okay, so big idea for right now is I just want you to be able to find your intercepts on a rational function.